Okay, so this video is to help students that are absent from class to follow along with the algebra tiles activity and to get you guys some background in that so that you can do the assignment on your own. So the first part of the activity we're going to do as a class, and that's the part that I want to walk you through here. So the first part is draw a sketch showing how each term below is modeled using algebra tiles. So algebra tiles are these. This is a set of foam ones, and we'll be working with these in class. And they come in 3 different sizes. So we have a big rectangle or big square. We have these like skinny rectangles, and then we have these little squares. And each of these represents a particular area. So the large square represents x squared, and here's how it represents it. So on your sheet, and you can do this on a piece of notebook paper at home. You don't have to have the worksheet. The worksheet just is to follow along. So you are welcome to just do this on a separate piece of paper. But the large square represents a square with an area of x squared. So this actually feeds into the area model that we've been working with, where each side of the large square is represented by the dimension x. So this is an x by x square, okay? Now, if you look at the way the algebra tiles are configured, the rectangle has the same, I guess, like length or height as the large square, which means that the height of that rectangle is also x, okay, because these would match up, okay, so they match up. So if the height of the large square is x, then the height of the rectangle here would also be x. Now that leaves us with, well, then what is the width? Now, for the purposes of using the algebra tiles, the width of this rectangle is 1. Okay, so if we were looking at area, the area of that square is x times x, or x squared. The area of this rectangle would be x times 1, or just x. And then that leaves us with the little squares. And if I line these up, you will notice that the dimensions of the little square match the smaller dimension on that rectangle, which we now know is 1. And so that means that this small square is has got a dimensions of 1, so a height of 1 and a width of 1. So the area of the small square is 1. So what we've done here is we've created this visual model with these 3 different sized pieces. The area of the large square is x squared, the area of the rectangle is x, and the area of the small square is 1. Now with that, we will be able to model all different kinds of polynomials and actually use the physical area and the manipulative nature of the algebra tiles to be able to factor trinomials. So the next step here is model the polynomial x squared plus 8x plus 15 and draw a quick sketch in the space below. So what we'll do in class is something like this. So each student has their set of algebra tiles, and we want to model x squared, and then we want 8 x's. So we'll go and collect 8 of these x's. So go ahead and collect them. I'll slide my sheet up a little bit so you can see them. Okay, there's my 8 x's, and then 15 of the little squares. So we'll go and find 15 of these. All right, and we'll take time to do this in class. This is about as hands-on as you can make factoring, so, and it does take a minute. Now what you can do if you're doing this from home is there is a website that I will link where you can have virtual algebra tiles, meaning that if you don't have the physical algebra tiles to lay them out and rearrange them on the desk, you can have the option of doing it on the computer. So I think this is 15, 1, 2, 3, 4, 5. Okay, and so that's how we would model the polynomial x squared plus 8x plus 15. We have 1x squared, 8 x's, and 15 of the small squares. So what you will do, and again, you can do this on your sheet at home, is draw a quick sketch. Quick meaning I do not want you spending like forever on this. So we would have one of the big ones. We're going to have 1, 2, 3, 4, 5, 6, 7, 8. Just make sure that they all look like rectangles. Okay, we are not going to get super picky about whether or not they are exactly the right size. And then 15 of the little squares. So I will do, that's 5, so I'll do 3 columns of 5, just like I had them laid out on the page. And that's literally all I want you to do. It should not take you much more time than what I did. You're following at home. You can pause the video for a moment and just like sketch that out. Okay, now here's where it gets kind of cool. We're going to arrange the tiles to factor the polynomial. Now, if you remember the whole idea of the area model, okay, is that we were looking at physical areas and we were looking at the areas that would form a rectangle. Now, what I think is super, super cool about this is that that will work with our model here. And so we will do this again in class, so this is what you're missing if you're not in class. We're going to play around with these until we can make a rectangle out of them. So I'm going to start by maybe, we got 8 of these, so I'm going to go ahead and put like 4 of them on each side. Now, one thing you do want to make sure you do is that the colors need to match up. Now, we haven't done the different colors. You might have noticed that the other side of these is different colors. We'll talk about that in a little bit. Okay, so I'm on my way to making a rectangle here, and I start placing my units in here. So here we go. Just kind of placing them in here. And what I'm going to notice is that I cannot make a rectangle with this. It's not going to work out. Okay, so I'm missing a piece. If I know mine are kind of moving around. These are lightweight ones, so they move around. But it doesn't quite work. I have a space here. So what that means is I have to rearrange stuff. So what I think I'm going to do is take this piece from down here, okay, and I'm going to slide it over here. And that means that these ones now down here are like hanging out. So I'm going to see if I can move those over here. And I think that's going to work for making a rectangle. Okay, and I'm trying to do this fast so the video isn't super, super long. But remember that if you're doing this from home, you did miss an entire lesson. So. Okay, and what I have here is a rectangle. Now what's really cool about this is this gives me the factors. Now I know that this arrangement is the same as the original arrangement because I didn't add or take away any of the pieces. So the area, the x squared plus 8x plus 15 is still here. X squared plus 8x plus the 15. So this is equivalent to the polynomial written out x squared plus 8x plus 15. Now I've just rearranged it, and what I've done is I've made a rectangle. If you look across the top of the rectangle, this dimension here is x. If I slide my sheet down a little bit, we've got that dimension. This is an x, and this is equal to 1. So this is x and 1, 2, 3, 4, 5. So this dimension is x plus 5. Going down the side, we have x plus 1, 2, 3. And so the dimensions of this rectangle are x plus 5 and x plus 3. What you're going to do on your sheet of paper is draw a quick sketch. Again, we're not going for super accurate, you know, bust out your ruler kind of accuracy, but we want to do enough of this sketch so that it becomes evident that we have done the factoring. So arrange the tiles to factor the polynomial, draw a quick sketch in the space below, and write the factors. So this will look like a big rectangle with 3 of the or big square with 3 of the rectangles down below, and 1, 2, 3, 4, 5, and then we'll have the 15. Sorry, this is like really messy. There we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there they are. And so what we have is x, and then we have 5 of the rectangles there, and x and 3. So my factors are x plus 5 times x plus 3. And if you were to multiply x plus 5 times x plus 3, you would get x squared plus 8x plus 15. And so what we've done is we've done this like algebra rearranging like of the tiles on the page to factor the polynomial. So we're going to do another one together. You'll notice that this is like a little bit of what they call in education gradual release. So the first one we do in a lot of detail, and we do it together, and basically everyone in class can copy down what I'm doing. I'll do this on the board, similar, we'll kind of go through this all together. Now the second one is up to you to model them on their own. So what I'll do in class is I will let the students, like with their algebra tiles, come up with the pieces for the modeling. So this one has 2x squared. So we will have 2 of the big blue ones, plus 7x. So we'll have 7 of these blue rectangles. 1, 2, 3, 4, 5, 6, 7. And 3 of the small ones. And so you would model that. And now it says, on your own, see if you can rearrange the tiles to form a rectangle. Sketch the rectangle below and write the factors in the space provided. So once we kind of check in, make sure everybody has the right tiles to model the polynomial, then I will let the class on their own take some time, see if they can come up with how to rearrange the tiles to form a rectangle. So if you've got that website open, you can go ahead, pause the video here, and just see if you can do it on your own. Get that little bit of gradual release in making up the lesson from home, and then you can unpause the video and I will go over it just like I would in class. Okay, like hopefully you did that and you're not just breezing through the video. All right, so let's go ahead. We'll put our 2 blue rectangles here, and I guess like we'll just start by putting some tiles here. Okay, so I have it 7, so I could do something like, whoops, like this, where I do 2 and then I put like 3 down here. Okay, and then I need to fill in with these 3, but you'll notice that that is not going to work. So what I can do is I could like move some of these down here, or like, and you can move them around. But I think what I want to do is take 2 of these and put them over here. Okay. And now I can take these 2 down here and rearrange them like so. And now I have my rectangle. So the dimensions of this rectangle would be x. Okay, remember that has a dimension of x plus 1, 2, 3. So x plus 3. Going down the side, I actually have 2x. Okay, I have x here and then another x, and then I just have 1. And so we will do a quick sketch of that arrangement. So we have 2 big squares and then a rectangle below, and then coming out to the side here we have 3. Let's slide the page up a little bit. So, and then we have the 3 little ones right in there. And again, this is confirmation that like you're not jumping online and finding the answers. You are going through the process of using the algebra tiles. So I am going to require that you guys show the sketches. Again, it doesn't have to be super detailed or neat or anything, just enough that, okay, yes, I did do the rectangle. This is x and this is 3. Here you have x and then another x again, which of course is 2x, and then we have a 1. And so in the spot where it says write the factors, the factors would be x plus 3 and 2x plus 1. And all of that will be done in class. Let me check the time on the video. So this video is about 15 minutes long at this point. It'll take longer for us to do that in class, so you are getting like the fast version of this. If you did pause the video, then you're probably running more what the pace in class would be, but hopefully you're getting the point. Now I want to take a moment and explore how negatives work. So you might have noticed that the backside of these are red, and the red represent a negative. So if I flip over one of these rectangles, where this would be positive x, the red represents a negative x. Now what's really, really important with this is that you remember that x plus negative x is equal to 0. So x plus negative x, so 3 plus negative 3 or 4 plus negative 4, whatever value you want to put in there, is equal to 0. Now what that means is that as long as you pair up your x's and your negative x's, you can add them or take them away from any given set of tiles, because if you add a positive x and you add a negative x to go with it, what are you really adding? You're really adding 0. And the same is true for our little ones. So this would be equal to 1, the yellow one, and this is negative 1, and 1 plus negative 1 is 0, which means that, again, as long as you add them in pairs, then you're not actually changing the value of your polynomial. You just got to make sure that you add them together. So an x with a negative x or a 1 with a negative 1. So we're going to go ahead and model. I'm getting down to the bottom of the sheet there. I can move my camera to the bottom of the sheet here, so it's just getting hard for space. X squared minus x minus 6. So for x squared, we'll have the blue x. We will have a minus x, so we're going to have the negative x, and now a minus 6. So we have, so we're going to flip them all over to have our model polynomial. So this would be x squared minus x minus 6. Now, it says follow along in class as we work together to make a rectangle with these pieces. So kind of watch how this goes. So if I try to make a rectangle as is, we're going to notice right off the bat that we have a bit of a problem in that we don't have any rectangles to put down here. We also have way too many squares, okay? So we have all these like squares. We have nowhere to put them. We're not entirely sure if like we should put them like so. This again, or maybe they go like this. Like we just do not know what we got going on there, okay? So we have a problem. We don't have enough pieces. Now, here's what we want to remember. X plus negative x is equal to 0. So if I bring in an x and a negative x, and I put them into this collection of tiles, I haven't actually changed the value of the tiles, because if I bring in an x and a negative x, what I've really brought in is 0. They're going to cancel each other out. Now, what you need to remember when you do this is that because of the way things factor, you want to pair your negative x's up together and your positive x's on a separate side. So you don't want to see an x and a negative x on the same side of the rectangle, because then they would cancel each other out on the same side. So we don't want that to go on. Now, I still don't have enough. I still have like too many places, but it's squares here. But I can kind of see right now, if I put in one more pair, now I have my rectangle. And so what do I have here is x, and now this is minus 1, 2, 3, because they are negative. So this is x minus 3, and this is x plus 2. So if you need to rewind that to see that again, go ahead and rewind it to see it again. I'm going to change the page out because we want to go on to the next page here. So one of the questions, let me move that up, that comes up is simply to follow along in class. So all I want you to do is watch the video here, just follow along. And what is one thing in this process that is new? Just paying attention. Well, what's one thing in this process, this is new, is that we have to add pairs of x and negative x to make our rectangle. And that should set you up for the rest of the assignment now that you've seen this done out. So it says, on your own or with your table mates. If you are absent today, you don't have the benefit of table mates. That's why it's great to be in class. Use the algebra tiles to model and factor each of the trinomials before finish for homework if needed. So the rest of the class period is going to be group work or individual work where students are going to work on the following problems, beginning with x squared plus 4x plus 3, and then moving on to, like, we have a 3x squared. We're going to have one that has like a negative in here, so we'll have to play around with those negatives. 4x squared, I don't know why, I was just having fun with that. And then 2x squared plus 5x minus 3. All of these can be done with the simple, like, single use pack of algebra tiles. And you'll notice that there is a website there. So mathsbot.com, manipulative tile. I think I might have it up here. Yep, so what you can do if you need to model that first one is model your x squared, and then you can click in your 4 x's and drag them over, and then your 3 1s, and then you can rearrange them. Now they are like arranged. Yeah, so like, let's say you arrange it like this and you're like, it's not going to work. Then you want to pull one of your x's from here, okay? Just so you have the horizontal, because you can't rotate them. But you should be able to use that in place of physical algebra tiles. You can take a look at the website across the top. And again, you can do this on separate pieces of paper. You do not have to have the worksheet, okay? You don't have to do this. Like, there's no reason why you can't do it on a separate piece of paper. You've got the website resource to get the virtual algebra tiles, and you've had the benefit of the lesson. So you should be good to go. Hopefully you can complete the homework on your own and come to next class prepared with your questions.